Hi everyone, our lesson today is Newton's universal gravitational law. Firstly, we know that all bodies in this universe attract each other under the effect of commutative force directly, which is proportional directly to the mass of each of the two bodies and inversely to the square of the distance between their centers, i.e. a force proportional by m1 multiply m2 over s square. Then F equal constant denoted by G multiply M1 multiply M2 over S square, where F is gravitational force commutative between the two bodies in Newton. M1 and M2 are the two masses of the two bodies in kilogram. S is the distance between their centers in meter. Lg, the universal gravitational constant. Also, the law of universal gravitational is defined as the inverse square law. We want to define the universal gravitational constant. Definition: it is constant attraction force between two masses, each of them 1 kilogram, and the distance between their centers equal 1 meter. It equals approximately 6.67 times 10 power negative 11 Newton meter square meter per square kilogram. Example 1. Two poles of masses of the first is 10 kilogram and the other is 5 kilogram. The distance between their centers is 0.5 meter. Calculate the gravitational force between them given that universal gravitational constant equals 6.67 times 10 power negative 11. Solution: we have F equal G times M1 multiply M2 over S squared. Then, by substituting Lg equals 6.67 times 10 power negative 11 times M1 equal 10 times M2 equal 5 over L distance 0.5 power 2. By calculation equals force equal 1.334 times 10 power negative 8 Newton. Example 2. Calculate the gravitational force between the Sun and Jupiter, assuming that the mass of Sun is 2 times 10 power 30 kilogram, and the mass of Jupiter is 1.89 times 10 power 27 kilogram, and the distance between their centers is 7.73 times 10 power 11 meter. Given that the universal gravitational constant equal 6.67 times 10 power negative 11 Newton square meter per square kilogram, we have F equal G times M1 times M2 over S square. By substituting in this rule, we get that F equal 4.22 times 10 power 23 Newton. Example 3. If the gravitational force of the Earth to the Moon is 3.11 times 10 power 24 Newton, and the mass of the Earth equals 6 times 10 power 24 kilogram, and the mass of the Moon equals 7 times 10 power 22 kilogram. Find the distance between their center, given that universal gravitational constant equals 6.67 times 10 power negative 11 Newton square meter per square kilogram. We have F equal G times M1 multiply M2 over S square. Given that F equals 3.11 times 10 power 24 equals Lg equal 6.67 times 10 power 11 multiply 6 times 10 power 24 M1 times M2 7 multiply 10 power 22 over S square. By simplification and by using calculator, we get that S equal 3 multiply 10 power 6 meter. Example 4. Calculate the mass of the Earth in kilogram, given that its radius length equal 6,360 kilogram, and the universal gravitational constant equal 6.67 times 10 power negative 11 Newton square meter per square kilogram. And the acceleration of gravity G equal 9.8 meter per second square. Suppose that a body of mass M1 is put on the surface of the Earth, whose mass is M2. Since the weight of the body equal gravitational force of the Earth to the body, i.e., that's mean M1 G equal G multiply M1 M2 over S squared. By cancelling M1 with M1 from both sides, we get that 9.8 equal 6.67 multiply 10 power negative 11 multiply M2 over S squared. By simplification and using calculator, we get that M2, the mass of the Earth, equal approximately 6 multiply 10 power 24 kilogram. Example 5. Calculate the gravity acceleration in meter per second squared to a body of mass 1 kilogram, putting on the surface of the Earth whose mass equal 5.95 multiply 10 power 24 kilogram, and the radius length of the Earth equal 6,360 kilogram. The universal gravitational constant equal 6.67 multiply 10 power negative 11 Newton square meter per square kilogram. The weight of body equal gravitational force of the Earth to it. M1 G equal G multiply M1 M2 over S square, where M1 the mass of the body and M2 the mass of the Earth. By replacing in the formula, we get that M1 equal 1 multiply G equal G equal 6.67 times 10 power negative 11 multiply M1 equal 1 times M2 equal 5.95 multiply 10 power 24 over S squared. By simplification and using calculator, we get that LG, gravity acceleration equal approximately 9.81 meter per second square. Now, comparing between the gravity acceleration on the surface of two planets. Let G1 and G2 be the gravity acceleration on the surface of two planets, whose masses are M1 and M2 kilogram, and their radii lengths are R1 and R2 meters, and the body whose mass is M is put on the surface of one of the two planets. With respect to the first planet, the weight of the body on the planet equal the gravity force of the planet to the body. Mg1 equal G multiply M times M1 over R square. With respect to the second planet, the weight of the body on the planet equals the gravity force of the planet to the body. Mg2 equal G M1 multiply M multiply M2 over R squared. By dividing equation 1 over equation 2, we get that G1 over G2 equal M1 over M2 multiply R2 squared over R1 squared. Example 6. A planet of mass equal 3 times the mass of the Earth, and its radius length is twice the radius length of the Earth. Calculate the ratio between the gravity acceleration of this planet and the gravity acceleration of the Earth. Let G1 gravity acceleration of the Earth, M1 the mass of the Earth, R1 the radius length of the Earth, and G2 be the gravity acceleration of the planet, M2 be the mass of the planet, R2 be the radius length of the planet. We have G2 over G1 equal M2 over M1 multiply R1 squared over R2 squared. We have M2 equal 3M1 and R2 equal double R2. By replacing in this formula, we get that G2 over G1 equal 3M1 over M1 multiply R1 squared over 2R all squared. By simplification, M1 cancelled with M1 and R squared cancelled with R squared, then we have 3 over 4. Example number 7. Given that the mass of the Earth equals 5.97 multiplied 10 power 24 kilogram. And its radius length equals 6.34 multiplied 10 power 6 meter. And the mass of the moon equals 7.36 times 10 power 22 kilogram. And its radius length equal 1.74 times 10 power 6 meter. Find the ratio between the gravity acceleration of the moon and that of the Earth. Assume that the gravity acceleration of the moon equal g1 and the gravity acceleration of the Earth equal g2. We have g1 over g2 equal m1 over m2 multiply r2 squared over r1 squared. By replacing m1 equals 7.36 times 10 power 22, m2 equal 5.97 times 10 power 24 multiply r2 equal 6.34 times 10 power 6 all power square, and r1 equal 1.74 times 10 power 6 all power square. By simplification, we get a ratio between two gravities, two acceleration equal 0.16, approximately 1 over 6. Acceleration of the gravity on the moon equal 1 over 6, the acceleration of gravity of the Earth, approximately. Thanks.